Hey guys, so today you're going to be doing a lab and I'm going to show you just kind of the overview of what you're going to be doing in the lab. But prior to that, I wanted to talk to you about different kinds of mixtures. So today in the lab, you're going to be going around to stations and trying to distinguish or determine, I guess, if the substances on your tray are compounds, elements, or mixtures. And you have items on your tray, and sometimes those items will give you big clues, but also on your tray, there will be some content information that you might need to use in order to get some clues as well, in order to fully be able to determine if something is a mixture, an element, or a compound. So I'm going to show you two mixtures. And one of the mixtures you're going to be able to easily identify if you see something like that as a mixture. The other one, not so much. So I have two mixtures. This first one is salad dressing. Okay. If you look at the side of the salad dressing here, you can see some layers. I've got a layer here, a layer here, a layer here with some little pieces mixed in. Okay. I even took the label off the back so you could see it a little bit better. This is a mixture. It's pretty easy to identify that it's a mixture because you can tell that some of these different parts are separated from each other. Pretty easy to tell. This is what we call a heterogeneous mixture. Some mixtures, however, look really uniform. It's because either some of the parts have been melted and combined together and have solidified, and so they mix really evenly, or typically another way that things mix together evenly is if they're dissolved in a solution, and usually water is part of that solution. So here is a mixture, lemonade, okay, that looks very uniform throughout, okay? And you might say, oh, maybe that's a compound and not a mixture. But if I ask you to take it a step further and I leave this lemonade out on a hot sunny day, maybe for like 4 or 5 hot sunny days, and I leave the lid off of it, what's going to happen eventually is the water is going to evaporate, right? And when that water evaporates, there are some parts of this lemonade that will not evaporate, right? It will actually leave some of that sugar and maybe even some of that lemon pulp behind. And so what that indicates to us, just like with ocean water, salt water, right? If you can separate those parts of this solution without changing them chemically. So homogeneous mixtures, which is what kind of mixture this is, okay, are a little bit more difficult to tell apart. So if you see an item at your station and you're not quite sure, you may want to look at the information on the tray to help you to determine, is it really a mixture or is it maybe an element or a compound? So I'm going to show you the slideshow that has the instructions. Again, this is available to you on Google Classroom. Okay. So let's look. I think this is the one. Yep. Okay. So here is the slideshow that gives the instructions, okay? Here is a little review of mixtures. So heterogeneous, hetero means different. You can see the different parts easily. So here you can kind of see molecules are more separated, just like you can clearly tell the cookie part from a chocolate chip cookie versus the chocolate chips, okay? You can identify the ice and the soda separately in that mixture, the parts of the pizza, the parts of the sandwich, the parts of the salad. So it's easy to tell that a heterogeneous mixture is a mixture because you can tell those things aren't bonded together. Homogeneous mixtures, homo means the same, and homogeneous mixtures look uniform or the same throughout. And so some of these are some examples of different drinks or other liquids that have really evenly mixed. Natural gas has several different gases that are mixed together, just like the air that we breathe. Okay, even though it's all clear, remember we've talked about that most of the gas in our atmosphere that we breathe in is nitrogen, and our bodies don't use that, right? So only the oxygen molecules is what our lungs filter out. And then there's something called alloys, and brass and steel are examples of alloys. So these are two different metals, or maybe three from the periodic table, that are melted together and combined, and they don't chemically bond together, but they mix really evenly, okay? And so those would be what brass and steel are. So they're really even mixtures. It's hard to tell. So what you would need to do is look at your tray and look at some of the other hints on your tray. So as you go through your stations, you're going to have about 3 minutes at your station. Your teacher is probably not going to have access to this timer, so she'll probably just set a timer on her watch or phone or something like that. This is the data table you'll be filling out. Notice that you'll go all the way through station 8, not through station 6. But if you're struggling, you can come back to this slide, and there's some hints that are being given to you on some of the parts of the station, like that show you how to fill out the handout appropriately, etc. So that's a nice little helpful hint slide for you. And then these are just pictures of some of the cards you'll see. So the background is the information that you'll see it on your tray. And then the photo is what your whole tray would look like, right? So here it tells you if there's a chemical symbol or a formula, it would be present. So that's a really helpful hint. And then it also tells you what you're actually looking at. Okay, so here you're looking at oil and water. It says oil and water on the top. You can see the oil here and the water here. It tells you what those different molecules present are. And so that should give you a hint as to whether or not is that a mixture or an element or a compound. Okay, if it's more than one compound, then it's a mixture. It's not just a single compound or a molecule. Okay, so your stations should all look mostly like these trays. These are the trays from last year, so you might have a little bit of a difference from this year, but you're just going to rotate through at 3-minute stations. You'll look at the pictures, look at the information on the slide, and you'll be answering your data table. If you have extra time between rotations, you can look at your post questions, or maybe you can take your journal with you and see if there's questions from one of the handouts earlier this week that you need to finish. So remember, the handouts earlier this week were the elements, compounds, and mixtures handout. That was a 2-page handout that you practice sheet that you needed to finish. And then the elements, compounds, and mixtures models handout that you needed to work through. So work hard. You have today and tomorrow to work on this lab and finish it. And then on Friday, you will have a quiz over everything you've done this week. So I hope you've been working hard, even though I haven't been there. See you guys soon.